Hi, everybody. Okay, today's lecture is going to be on cylinders. This is very easy, very short. So let's see how you define a cylinder and what, well, everybody knows what a cylinder's graph looks like, so that's not the issue. But we need to see what's the equation like when you look at an equation in three space. So today we want to talk, or at least right now, let's see. We want to talk about, let me get that wire out of the way. Let's get this focused a little bit. We want to talk about cylinders. And it's better to pick a pen that has ink in it. Okay, here we go. Okay, so this is pretty darn easy. Let's refocus that. Okay. In 2D, if you look at something that has the equation x squared plus y squared equals, I don't know, 4. That's the equation of a circle with center 0, 0, and radius 2, right? In fact, if you had x squared plus y squared equals r squared, then the radius is r and the center is 0, 0. And you could move it around a little bit by, if you looked at x minus h quantity squared plus y minus k quantity squared equals r squared. This is a circle with center, geez, can't write, center hk and radius r, okay? And now we're going to 3D. Okay, so now let's look at the equation I wrote down a minute ago. Suppose I do x squared plus y squared is equal to 4. So that's the equation of a circle in the xy plane. So let me, in my very limited ability, draw the equation of a circle in the xy plane, hopefully. Okay. So that's a circle of radius 2 in the xy plane. Okay. But what is the xy plane? So this is the xy plane is the plane z equals 0. But you see, z doesn't appear in this equation. So any value of z works. So this works at z equals 0, but it would work equally well if we look at the plane where z equals 1. And now you could look at the circle x squared plus y squared equals 2. Okay, that looks really bad, but assume that's a circle of radius 2. That also satisfies the equation, even if it's in the plane z equals 1. In fact, z doesn't appear, so x squared plus y squared equals 4 looks like a circle of radius 2. Radius 2, centered at 0, 0. And it intersects any plane of the form z equals a constant. CTE is my favorite abbreviation for constant. It's the French abbreviation. I like that. Okay. So at every stage of the game, no matter which plane horizontal to the XY plane any plane parallel to the XY plane you stack up, you still see a trace of a circle when you look at that equation. And so, in other words, if you stack them all together, since that works for any z, what you get is a circular cylinder, because you're basically stacking circle upon circle or circle upon circle. Each one has radius 2, and it's a continuous thing. Doesn't matter what Z is. Let me try to draw my axes. Okay, so we get a cylinder of radius 2, centered at the origin, and it's an infinite cylinder. It goes infinitely long in both directions. Okay, and that's the graph of x squared plus y squared equals 4. And it wouldn't matter if it was just any number here. You take the square root, that's the radius. And you can off-center it. You can make it have a center hk by just taking x minus h quantity squared times y minus k quantity squared, just like you did for a circle. So that's it. That's all there is. Anything of this form that looks like the equation of a circle in 2D, it actually gives you a cylinder in 3D. That's it. That's all there is to cylinders. Very easy. Okay, bye.